Now, this may be a bias for us carbon-based, water-filled sacks of life called humans, but let's imagine that you need something like our biology to make intelligent life. That means that if you are making life like us, you need something to dissolve those chemicals in, because basically life is a complex series of chemical reactions. You need something to dissolve those chemicals in, and water is a wonderful solute. Right? So because we're based on water, and because water does a wonderful job in dissolving chemicals, we expect that other kinds of life will also depend on water. And water has to be in liquid form. If you have steam, you can't dissolve anything, and if you have ice, you can't dissolve anything. So we need water in liquid form to develop life. Now, Earth does that very nicely. We have most of our planetary surface is water, and because the Earth has a nice temperature, it's not too hot. If it were too hot, the water would boil away. If it was too cold, the water would be in the form of ice. So we are in exactly the right place. It's just like Goldilocks. If you want your porridge, you want it not too hot, not too cold, but you want it just right. Now, the thing that determines the temperature of a planet is how close it is to its central star and how hot that star is to begin with. All right? So, for instance, suppose we lived on Venus. Venus is only 70% of the distance to the sun that we are, so it's a bit closer, 30% closer to the sun. Venus has a temperature that would melt aluminium. Its atmosphere is all carbon dioxide. Its atmosphere is so thick it would be like being 90 times the Earth's atmosphere would be the surface pressure of Venus. And it's rains sulfuric acid. Really not a very pleasant place, and life couldn't possibly survive there, mostly because there's no liquid water, because it's too hot. If you step back to Mars, now Mars is further from the sun than the Earth. Mars is too cold. There is no liquid water on Mars now. There is some evidence that there used to be liquid water on Mars. You see canyons and river deltas, at least the dry river deltas that used to be there, but no longer. So life presumably couldn't easily exist on Mars. Earth is at exactly the sweet spot. So this is what astronomers will call the habitable zone. It is that distance from the star at which a planet can orbit where the water would be in liquid form, where the temperature is not too hot above the boiling point of water or too cold below the freezing point of water. So water would exist in liquid form. So you need a planet orbiting in some zone that's between 0 and 100 degrees. Now for a tiny cool star, that's actually quite close, right? The closer you are to a heat source, the hotter you get. So if you're cold at night and you want to get warm, you stand up close to the fire. If you're across the street, you don't feel the fire at all. So there's a particular distance that you have to get from your central source. If you have a cool, tiny little star, then you have to get really close. And so the habitable zone would be very close to that star. If you have a star like the sun, you want to be about 1 astronomical unit, the distance of Earth's orbit away from the sun. If it's an even more massive star, you got to get further away. All right, so the habitable zone will change depending on the type of the star. We now are finding planets through this transit technique and through the velocity technique. We are finding planets in the habitable zone of their parent stars. So we're finding extrasolar planets that are at the right distances where water will be liquid. We're not yet at the point to determine whether or not there's life on these planets. That's a tricky business. The way you probably do that is to look for things that life makes, like, for instance, free oxygen. Oxygen is a terribly corrosive material and wants to bind up with other things. So left to itself, oxygen combines with, say, iron and makes rust. If you look at the surface of Mars, Mars is red because it's rusty. Right? Now, Earth generates free oxygen from the presence of life. Plant life makes free oxygen. And so if you were to examine an atmosphere of another planet and saw oxygen in it, you would say, okay, got to be life there because you have to replenish the oxygen somehow. And the only way we know how to do that is life. Now, there may be some other chemical markers for life, but that's a very nice one, looking for the free oxygen. But the planets are tiny, they're very far away, they're orbiting a star. The best way you might want to do it is to try to take a spectrum of a planet that's passing in front of its star and using the light from the star as a little beacon and look for little absorption lines of oxygen, of free oxygen. And that might be possible. Not today, but in the next 10, 20 years, we might be able to see these signatures of free oxygen in the atmospheres of other planets. Now, you asked also about the habitable zone in the galaxy. Well, galaxies, like solar systems, have some interesting things going on in the center of them. Many galaxies have what are called active galactic nuclei. These are essentially giant black holes, supermassive black holes, with material spinning into them. And that material spinning into them, falling into them, heats up and creates X-rays, gamma rays, and beams of radiation. You don't want to get too close to that either. So if you're too close to the center of the galaxy, the gamma rays, which would induce mutations and/or death in strong enough doses, would not be conducive to the formation of life. Similarly, suppose a star blew up. I mentioned supernova way back in the last lecture. If a supernova blew up, exploding star, that would generate a lot of radioactive material, a lot of energy, a lot of gamma rays, which could also destroy any life that had formed. So you want to be far away from the center of the galaxy, well, at least out of its influence. So, maybe a good, thousands of light years from the center of the galaxy. And you want to avoid any supernova popping off near you. Now that happens at random, so maybe we're just lucky.